Hi everyone, this is Mrs. McCoy with an Earth Science podcast. Please make sure you have your interactive science notebook out and that you're ready to stop the module and record your key ideas and any information into your interactive science notebook. Remember, you need to be an active listener. You need to write down what you think is important and create your own notes. So today, the topic is density. Density is the amount of matter that's in something, defined as the ratio of an object's mass to its volume. But I really think of it as how many atoms are in something, are crammed into anything from a stapler to a rock to the atmosphere. It's the amount of matter in a specific object. Here's an example. The box on the left, box A, has 70 molecules in it. The box on the right has only 2. So we say the box on the left is much more densely packed because there's a lot more stuff crammed into the same given space. So synonyms that you'd need to know would be, for box A, the box has a higher density. It is more dense, we can say, or it has an increased density. It's heavy. It would sink. So those synonyms all apply to box A. For box B, we would say that that box has a lower density or it's less dense. It's got a decreased density, it's lighter, and box B would float. Those are all synonyms that can be used when talking about density. Density is a physical property of matter. It's a physical characteristic. Just like your height or your eye color describe you and the way you physically look, density describes the physical characteristic of any object. As a matter of fact, it's kind of cool to know that humans have an average density of 953 kilograms per meter cubed. Kind of good. Kind of cool. That's my cat. The same substance, you have to remember, has the same density. That means that the density would not change due to the shape or size of the matter. So here's an example. Gold has an average density of 19.3 grams per cubic centimeter. They're all gold, so like the property says, the same substance will have the same density. So gold has a trademark density. It describes gold. But if I were to take that gold necklace and break it in half, it's still gold. So it would still have the density of 19.3 grams per centimeter cubed. So it's really important to remember that the size and shape of the object have no impact on the density of the substance. Okay, it's a physical trait to describe something. So that would create a static relationship when you're comparing the size of an object to the density of the object. No matter what the size, the density would stay the same. So no matter how much gold you had, it would still have a density of 19.3 grams per centimeter cubed. So when you're figuring density, you don't have to freak out. The formula is on page 1 of your reference table. You never need to memorize it. Density equals mass divided by the volume. Like we said, it's a ratio. Something you're going to want to remember are the units. You can have grams per centimeter cubed for density units, compound units, or you could have grams per milliliter for density if you're dealing with liquids. So you don't have to memorize the formula. It's on page 1, but you do need to know how to manipulate the formula. The Regents might ask you to solve for a mass. In a lab, you might have to solve for the volume. So you can't just go with the density formula. You have to be able to figure out how to mathematically solve for both mass and volume in addition to density. So while you can't, while size and shape have absolutely no effect on density, there are two things that can change the density of an object. If you change the temperature of the object is one of them, or if you change the pressure that's applied to the object, it can change the density. Let's start with temperature. When dealing with temperature and density, when you heat something, it will expand. When you add energy to something, the molecules actually move further apart. They move more. When this happens, the object becomes less dense. When it becomes less dense, it will rise. The same exact thing works opposite. When you remove energy from a substance and you cool it, the substance will contract. The molecules will move closer together and the object will become more dense when it gets cooled, and that object will sink. So, temperature affects density and makes molecules either move faster or slower, which makes them expand or contract. So if I take room temperature air, now watch the graduated cylinder and the molecules, and I cool it, the molecules have less energy, they're closer together, they take up less space, and they become more dense. So they sink. If I take the same molecules, warm them back up to room temperature, they expand a little bit, they are moving more, they have more energy, but if I make them even hotter, they expand even more, become even less dense, and rise or float. So as temperature increases, the density of the substance decreases, so that would create an indirect graph relationship. The second factor that can change the density of an object is if you change the pressure exerted onto the object. So substances under only a little pressure will expand. The molecules move apart, not as much stuff pushing on them, and the density will actually decrease. Things will rise or float. But if you take the same substance and you put it under a lot of pressure, the molecules get contracted. They get pushed together and they take up less space. So the molecules move closer together, density increases. We know that that will sink. So that type of relationship, when as pressure increases, density increases, is a direct relationship. So when we talk about the phases of matter in a phase change diagram, solids will always be more dense, have a higher density than a gas. Liquids would be in between. So as you add heat energy, you can change the density of matter. This is all true except for water. So when we're talking about solids, liquids, and gases, for everything, solids are more dense, followed by liquids, and least dense would be gases. But with water, it's special. While the density of most substances increases when a liquid becomes a solid, with water, the solid water is actually less dense than liquid water. It's something you have to remember. It's on page 1 of your reference table. Water is most dense in a liquid phase at 4 degrees Celsius and less dense as a solid. And thank goodness that ice floats. Below you can actually see the densities of water at different temperatures. And if you see, water has a density of 1 at 4 degrees and a density of 0.9999 as a liquid at 0. So that's it for today for density. Thanks for listening. Make sure you get your notes, stop the video, and rewind me. Goodbye.